Hello, I'm Adam Stewart. I'm a network specialist at Microsoft, and in this video I'm going to talk about network considerations for Skytap on Azure. And these can be a little bit different to regular Azure networking. So if you're used to working with virtual networks and ExpressRoute, then there are some additional considerations when connecting in Skytap to the customer's environment. The audience here is CSAs and internal technical staff at Microsoft, and also people working at partners helping customers move their IBM workloads to Azure. Okay, first thing to mention is just check the date on this presentation. The platform does change in terms of the features it offers, and there may be other options in the future on how to connect Skytap into Azure. I'm going to start by talking very briefly about Skytap and what it is, just in case you're not familiar. And then I'll talk about some of the things which, in my experience, are good to get on the table and discuss during that discovery phase in the project early on, just to make sure you don't have to come back and cover old ground. And this again is through the lens of networking. There are, of course, much broader things to talk about in any migration project, including a Skytap project. And the idea here is to really understand the customer's current way of networking, to make sure that you can align the Skytap design with that. And then we'll talk about how Skytap normally works, why it's a little bit different to regular VNets, how it connects to on-premises, how it connects to Azure, how we can work with security, how we can start thinking about Skytap across global regions, maybe America, Asia, and Europe. And then we'll talk a little bit about some of the networking inside of the Skytap platform. Okay, so if you're watching this video, you probably know what Skytap is, but just in case you don't, this is if you've got existing IBM AIX workloads or IBM I workloads on premises, and you're doing a big company migration of applications and data into the cloud, and you can migrate things like virtual machines, etc. But when you come to migrate these more traditional workloads, you can't just drop them inside of an Azure virtual network as a virtual machine. And what Skytap does is offer a service inside of the Azure regions that let customers migrate those workloads relatively seamlessly. So early on, the first thing you want to understand is, how does this customer already do their networking in Azure? And which regions are they in? Are they in West Europe, East US? Are they in Asia? And then sketch that out and understand, well, where is my Skytap deployment going? Maybe the customer's in the US and Europe for regular Azure, but you're just putting in Skytap into Europe. Or maybe you're putting in Skytap into Europe and America. That's one of the most basic things we need to think about up front, because of course, where you put the pieces of the jigsaw, ultimately you have to connect them using wires, and that is the network design. We then want to ask the customer about, what does your current ExpressRoute look like? Which points of presence are you using? How big are those ExpressRoutes? Are they already utilized quite heavily? If you've got a 10 gig ExpressRoute and you're only using it perhaps to 1 gig maximum, then there's much more opportunity to use that existing connection for Skytap. Whereas if you've only got a 500 meg ExpressRoute and that's already maxed out, you may have to consider upgrading the current ExpressRoute or putting in a dedicated ExpressRoute just for Skytap to facilitate the Skytap migration itself. Then it would be good to understand, where are the existing customers' data centers, where these existing IBM workloads are hosted, and then get a feel for how big these workloads are, what is the size of the data set, and then you can do some high-level reverse engineering, right? So this is my data set, this is my migration window, so this is how long it's going to take me roughly to migrate based on this size of ExpressRoute. Another key area here is to think about encryption. So we see a lot of customers inside of regulated industries like healthcare and government already encrypting at the network layer between their on-premises locations and Azure. And we need to understand if that same constraint or design requirement is going to apply to Skytap on Azure, because that will fundamentally change how you configure the networking. I'd say by and large that probably 95% of customers don't have that because they trust their network, they trust Microsoft's network, they trust a bit in between, or they run secure applications over the top. It's typically regulation that mandates people to do that. We then want to talk to the people inside of the customer and Microsoft who are responsible for their existing traditional virtual network design. So are you running a hub and spoke network? Are you running virtual WAN? How many spokes do you have? Are they split up into business units? How do you handle production and non-production? Is it a completely separate environment? Is there other ExpressRoute gateways, or is it consolidated? This is going to have an impact on what your design looks like, because you might be asked to mirror that same separation in Skytap, which might require different ExpressRoute circuits. And then finally, we want to talk and spend a good amount of time on network security. And this is fundamentally asking at the network level, where are we filtering the traffic? Where are we saying IP address A can talk to IP address B? The customer's probably using some sort of network security appliance in the virtual network. Might be an Azure firewall, could be an NVA by somebody like Cisco or Palo Alto or Checkpoint. So when we connect in Skytap, how are we going to fit into that model? Are we going to use the on-premises firewalls? Are we going to put firewalls in Skytap? And understand what the customer does with those firewalls. Is it just basic layer 4 firewalling, or is it something more advanced? Is it IPS IDS or some sort of complex layer 7 inspection or rule set? It'd be good to know if they're settled on a single firewall vendor. Are they multiple vendor? Are they vendor agnostic? Do they have any specific requirements around login? So some customers, again, in highly regulated industries might say, any traffic that comes into the cloud or out of the cloud, we want to at least log it for auditing purposes, source, destination, IP address, and port. You also want to understand, when I put a workload on Skytap, am I going to need to access it from the internet, or will I need to talk from Skytap to the internet? Because there are different patterns we can use to facilitate that. So probably understand how is the customer doing that today? Have they got a virtual network? When a VM in that virtual network talks out to the internet, how does it do that? Does it go back to on-premises and go out of a DMZ on-prem? Does it go out of a firewall locally? Does it use an Azure firewall? And what does that look like? And then the last one here, which is good to mention, is sort of remote access. So if you have got remote users, which of course is more and more frequent these days, do they VPN into Azure today? Do they need to VPN into Skytap in the future? What does that look like? When you've done that, you can sketch out at a high level what the customer's current Azure environment looks like, just to give yourself a feel for, okay, here are the regions, here are the on-premises locations, here are the circuits. This is what an example might look like. And then you will iterate on this to get to the Skytap network integration design. When you've captured the network security requirements, this is how that might look in a diagram format. So in this diagram here, we show how when the customer normally talks from on-premises into a spoke virtual network inside of their regular Azure environment, they're using that purple line. So they're pushing that traffic through a checkpoint firewall in this example. And again, you can use that to drive out the conversation of what they need in the Skytap design. In this design, we're also showing the red line on how traffic's controlled to and from the internet. And then the green line's talking about how do I get from one VNet in Azure to another VNet in Azure. And that could be asking how do you get from one business unit to another business unit, or how do you get from production to non-production. And as you can see on this diagram, that equally applies to region traffic as well as traffic inside of the same region. Okay, so we've understood the customer's existing network requirements, existing network topology. We're talking the same language, and now we're going to move on to explaining to the customer why Skytap is a little bit different to just deploying another virtual network. Skytap is not picking up something on premises and transforming it to put on a VM on a VNet. It's putting it on the Skytap platform to make that migration a bit more seamless. Okay, and this is where things differ from that regular VNet model. So here in this diagram, we've got the green boxes at the top, and that represents Skytap on Azure. And down at the bottom here, we've got the customer's existing hub and spoke environment. And as I said, rather than dropping Skytap into a virtual network, what we do is we use ExpressRoute inside of the Azure region to bridge that gap between Skytap and a customer's VNet. So this box here is representing Azure West Europe. You can see Skytap lives inside of the Azure region. But to bridge that gap between the worlds, we use ExpressRoute. And to do that, we deploy a circuit. So this red circuit here is deployed in the customer's Azure subscription, the same subscription where they deploy all their normal workloads, like ExpressRoute gateways and VMs, etc. But this is a special circuit in the sense that it lives on equipment inside of the Azure region. It doesn't live inside of a peering location, which is where this blue circuit lives. And this is the customer's existing blue circuit that gets them to their existing on-premises locations. This red circuit is completely inside of Azure, and that can be a little bit confusing at first. It's a different model, and we have to spend some time wrapping our hands around that to understand it. But this is the only way in which we can connect to Skytap today. You see here we have these DMSEEs, and they are dedicated Microsoft Enterprise Edge routers. So these are physical routers in the data center that we use to get to Skytap. And that differs slightly from a terminology that you might have seen before, which is MSEE, or Microsoft Enterprise Edge. And those are the routers that live in peering exchanges that facilitate these blue circuits that get customers to their existing on-prem networks. And we're going to use this blue and red color scheme throughout to make it clear. So in this diagram here, we've connected the red Skytap circuit to the customer's existing ExpressRoute gateway. So the ExpressRoute gateway kind of sees Skytap as a remote on-premises network and learns the routes via BGP and doesn't actually, from a network level, it doesn't understand that it's any different to a regular customer's on-prem network. What that means from a connectivity point of view in terms of customer VNet into Skytap is that as soon as you make that connection between the red circuit and the ExpressRoute gateway, all of the customer's VNets can start talking to Skytap completely inside of the Azure region with traffic staying on the Microsoft backbone. And you can deal with those traffic flows just like a regular on-prem environment. So you can insert, for example, in this flow, the green line here is being traffic engineered to pass through a checkpoint firewall. And you could do that for VNets to Azure traffic. You could insert a security appliance in that flow there. If we think about how to connect a on-premises environment into Skytap, this is where we need to think a bit more deeply about how this works. So in this diagram, we see the customer's ExpressRoute gateway in the VNet connected to Skytap on the red circuit. And we see the customer's ExpressRoute gateway connected to their on-prem network via the blue circuit. And the important call out here is that ExpressRoute gateway doesn't act as a transit router. So if you just configure things as per this diagram, Skytap would have no idea that their on-premise networks exist, and their on-prem locations would equally have no idea that Skytap exists. The prefixes wouldn't be sent from left to right. And that's by design. That's how Azure networking works. So we need to change that behavior to let the red circuit and the blue circuit talk to each other so that Skytap can see on premises and vice versa. And we do that using a product that has a name in Azure. It's called ExpressRoute GlobalReach. ExpressRoute GlobalReach is not just used for Skytap, it's used for other Azure dedicated workloads such as Azure VMware Solutions, and it's also used for other customer requirements. So if customers got a blue circuit in West Europe and a blue circuit in Asia, they can configure the Microsoft network using GlobalReach to send traffic between their on-prem data centers, almost like as a global WAN for their on-prem network. So GlobalReach is this useful tool that we can use for certain requirements, and connectivity to Skytap is just one of those requirements. So in this diagram here, what I've done is taken my red circuit, that's for Skytap, and I've connected it to the blue circuit by linking those two circuits using GlobalReach. And as we said earlier, this red circuit and the blue circuit is in the customer's Azure subscription. That means they've got full rights to do whatever they want with these circuits. That includes setting up GlobalReach between them. So this is a completely customer controlled operation, doesn't need intervention from anybody at Microsoft or Skytap. Now the question might come up, do I need to do anything to the blue circuit? And that depends. So if you just configure the network logically as I've shown here, all of the Skytap routes will start getting advertised to the customer on-prem, and they can just consume them without doing anything. But where you have to think a bit more deeply on this is in terms of the network throughput requirements. So as we said earlier, when we captured the customer's existing environment, is it a 10 gig circuit? Is it a 1 gig circuit? What's the current utilization? If you plan on running a Skytap migration that needs 2 gigabits per second of bandwidth for 3 months, maybe you need to think about upgrading that blue circuit or adding a separate blue circuit, as I'll show in a later slide. And the main thing to also appreciate in this diagram is that, yes, connecting GlobalReach has enabled end-to-end connectivity between on-premises and Skytap, and the green line represents that. But what we've done in that process is we've bypassed the customer's existing virtual network. So traffic comes in from on-prem into the Microsoft Edge network in a peering location, travels across the Microsoft backbone into the dedicated Microsoft routers that connect to Skytap, and then flows down into the Skytap environment dedicated to that customer. You notice how that green line doesn't go anywhere near the customer's existing ExpressRoute gateway or firewalls, and the implication of that is any controls and features they had in the VNet do not apply to that green line. And we'll talk a bit more about the implications and the workarounds for that a bit later. One of those implications is that clearly the green line bypasses the customer's hub VNet, and therefore you cannot use the existing checkpoint firewall in this example to do layer 3, layer 4, layer 7 firewall in between the Azure region and on-premises for the Skytap flows. Therefore, if using GlobalReach, we need to explore, are there other points in that path where we can implement our required network controls? And the areas to explore here are, number one, there is some work happening on the Skytap platform to natively support x86 network virtual appliances. So for example, you could deploy a checkpoint on Skytap and insert that in the green line. That work is ongoing, so I would check with Skytap directly on the supportability of that. Number two is, well, of course, you can address this at a different level. You can step up from the network level, go to the application level, and depending on which aspect of the application you're using, there's going to be security level controls for login, etc. So if you have a holistic conversation about the full security stack, maybe you don't need network security in this particular example. Number three here is a pattern that I've seen used quite a lot, and that is a lot of customers who connect ExpressRoute into Azure, so the blue circuit, will have some sort of cloud edge function, which is not only doing routing, it's also doing firewalling. So you could implement the layer 3, layer 4 rules at that point, before the traffic even goes anywhere near the Microsoft network. You could say this IP on-prem can access Skytap, this other IP address cannot, and that can be instantiated on the physical security appliances that you have there. Just one more point to note on this slide, and that is around the circuit provisioning, so that red triangle there, and how that works. Well, you deploy it from your Azure subscription. As we said, it lives in your customer subscription, and the first step is to request from Skytap operations that your subscription be allow listed to use Skytap as a provider on the drop-down list for the ExpressRoute circuit resource. Once you have the ability to do that, you choose Skytap as the provider, you choose the right region's peering exchange, and then you choose your normal ExpressRoute attributes, including do you want the circuit to be a standard circuit or a premium circuit, and that's got some implications which we'll cover in a little bit. And then when you've completed that process, just like with the normal ExpressRoute circuit, you get a service key, and you give that service key in this instance to Skytap operations, who will finish that circuit provisioning process. Here's an example of a customer that's decided to deploy a dedicated circuit, the green circuit here, for their Skytap project. So this customer looked at their blue circuits here and said, okay, I use these blue circuits today to get from Azure, my Azure VNets to on-prem. When I put the Skytap workload on that blue circuit is either not going to have enough bandwidth, or we can't increase it, or we want to keep these workloads separate. So they deployed a green circuit and a red circuit. So the red circuit is the one we've talked about already. The green circuit is a separate new circuit that lives in the regular peering exchanges, and we peer them together again using ExpressRoute GlobalReach. And there's a few benefits here. One benefit would be that the routing is completely separated. So if you've got a requirement to separate the security when it lands in the customer network, there's some additional options there. Okay, so we've understood the customer's existing network. We've explained to the customer how Skytap is a little bit different, how we use ExpressRoute and ExpressRoute GlobalReach as our tools in the tool bag to get them talking to Skytap from on-prem and in Azure. The security strategy has been agreed. So let's talk a little bit about pricing implications. As I say, this red circuit lives in the customer subscription as a normal resource, and therefore it incurs billing costs, just like their blue circuit would incur billing costs. They're not packaged as part of the Skytap solution. So let's think about what that means. So the first thing with ExpressRoute pricing is this red circuit here will incur a monthly recurring charge, just like the blue circuit incurs a monthly recurring charge. So for example, in West Europe, a 1 gig circuit, standard circuit using sort of pay-as-you-go billing will be roughly $430 per month. That will show up on the customer's Azure bill. And then in terms of additional costing, we then want to really make sure we understand the variable networking costs. And these are the ExpressRoute meters that are charged on a per gigabyte basis. And where these meters will activate are just like a regular circuit. So with this blue circuit today, if that customer pulls data out of Azure, they get charged a per gigabyte rate, unless it's an unlimited circuit, which is pretty rare. So just the same on this red circuit, if they pull data out of the circuit, they will get charged for it. What's the implication of that? If they send traffic from the VNet, and it goes into Skytap, that red circuit will incur them with the charge on a per gigabyte basis. The same thing applies here. If they pull traffic in from on-prem, that meter on the red circuit is charged. And that meter will vary based on the zone, the geographical zone within which this ExpressRoute circuit is placed. But for example, in West Europe, the Skytap egress circuit costs will be about 2.5 cents per gigabyte. And that's all you need to think about if you're coming from the VNet into Skytap. This sort of connection here between the gateway and the circuit is not charged. Where we need to think about some additional costs in that chain is when you're coming from on-premises, and that's because we're leveraging GlobalReach. GlobalReach is a service that is costed on Azure, and it's costed both on the source circuit, so the blue circuit, if you're coming from on-prem, and the destination circuit, the blue circuit here. So if you pull data from on-prem into Skytap, you come into Azure, which is free, you leave this blue circuit, and you trip the GlobalReach egress meter, which is $0.02 or 2 cents. You then come into the red circuit via GlobalReach, which trips the GlobalReach inbound meter, again 2 cents. And then you also trip the normal egress charge. So data from on-prem into Skytap in West Europe using this model is going to cost you 6.5 cents per gigabyte. Everything I've talked about so far is thinking about Skytap through the lens of a single region. So talking from a single Skytap instance to a single Azure region or a single circuit on-prem. But what if your customer is doing multi-region? They're in multiple regions in Europe or in Europe and in America. There's some additional things you need to think about. So let's talk about the sort of front-end access and the implications of that globally. A bit of a busy diagram, but let's explain what's going on here. At the top here, we've got West Europe, which is representing Skytap West Europe. And that's got the GlobalReach connection to the green circuit, which goes back to on-prem. And we've got the same thing down the bottom. We've got Southeast Asia, where they've also deployed Skytap. So Skytap on Azure in multiple regions. And they've got the same thing replicated. Skytap circuit, GlobalReach to a circuit in Singapore, back to on-prem. But the question might be, well, what if my West Europe region goes down? How do I then get to Southeast Asia or vice versa? And that's where you might need to think about premium circuits, because these red circuits here, to connect this red circuit from one time zone to another time zone in Azure, we call them geopolitical areas, you need a premium SKU. So probably the takeaway on this slide is there are different ways to sort of slice this global region problem. You can use premium circuits on Azure, which is the sort of purple line here. You can use the green line here, which is configuring the customer global network to route traffic globally. There's pros and cons to each. I would say if you're working on a global Skytap design, then you probably want to involve either a network specialist at Microsoft or a network specialist at Skytap to engage with the customer and just go through some of the nuances of this. But really the idea of putting this slide here is just to get you thinking about, okay, if it's a global customer, there are additional considerations here, and maybe the circuit needs to be different SKU and connected in a different way. A global Skytap design with Skytap in multiple regions is also going to potentially introduce a requirement for the Skytap instances to talk to each other for purposes of replication. And there's a couple of different options here, depending on what replication method you're using. So this is a bit of a simplified diagram. Again, Skytap in multiple regions. Everything to the right-hand side of this diagram is customer connectivity, which I dealt with on the previous slide, but we're now more focused on the orange and green boxes here. So inside a Skytap, like I say, but depending on how you're doing replication, if you're doing the snapshot replication, then that's going to be replicated out of band for the customer. So the customer's not really going to think about that. Skytap in West Europe will have back-end connectivity to Skytap in Southeast Asia, thanks to the co-engineering between Skytap and Microsoft. And that will all happen behind the scenes on the Microsoft network, and the customer will never have to think about that. That's kind of similar to how Azure Storage Replication works for things like GRS. But there are some scenarios where the replication for the customer is going to happen in the customer networks, kind of on the front end. So if you're maybe replicating to LPARs and you're using like AZ copy, and that's all being handled by customer virtual machines inside a Skytap, that's using customer IPs. It's not using backend IPs. And at that point, you need a way for those two Skytap instances to talk on the front end between regions. And that's where we can use GlobalReach again. So for this customer, we've deployed the regular red circuits on the right-hand side here to get to their on-premise environments, but we've also deployed some additional circuits, again, on the dedicated equipment for Skytap, but these are circuits that will be just used for replication between Skytap. So these orange circuits here, they will be premium circuits to go from West Europe to Southeast Asia. And we will again use the GlobalReach tool to connect those circuits and provide that path for replication on the front end. And again, the same sort of commercial model that will incur cost both for GlobalReach and for the standing charge for the circuit. As I said earlier, the default pattern and the recommended pattern for connecting Skytap is to use GlobalReach, and we talked about how that would bypass the customer's virtual network and mean they have to implement their network security controls at a different point in the network. Now, there will be some cases, especially if your customer's running encryption between on-prem and Azure today, where those are not suitable solutions or acceptable by the customer's InfoSec team. So there are some alternate patterns for connecting Skytap to on-premises. And I'll go back to what we said earlier. The purple line here doesn't work by default. So effectively, to make that purple line work, because the ExpressRoute gateway doesn't act as a router, we need to think about what workarounds we have on the platform. This example here is effectively saying the purple line bypasses my checkpoint firewall. How do I make that work? And again, just to reiterate the point, these are solutions which should only ever really be talked about if the default patterns are absolute showstoppers for a customer. In this diagram here, I'm explaining how the 172 range on Skytap isn't known by the 10 range on premises and vice versa because of what we talked about before. The first workaround that we can do is to use network address translation. So in this example, I've got a checkpoint firewall and I'm configuring it to translate all of those 172 IPs to IP addresses in the VNet and vice versa. Now, this does technically work on paper. There's a lot of caveats here. It works generally on a one-to-one IP basis. It's quite tricky with dynamic NAT because of scale limits. All that traffic goes through a firewall, so it's very expensive and tricky to manage in terms of throughput. If you're dealing with lots of ephemeral ports, again, you might hit scale limits. And effectively, all of this is manual configuration inside of a firewall, which is effectively a black box on the platform. So yes, technically it does work. Should we recommend it for customers? Absolutely not. Workaround number 2 is going to use Azure Virtual WAN. And this is a pattern which I think will prove quite popular in the future because it's actually quite straightforward. So remember earlier, I said that we could not bridge the purple to purple line, or purple to red in this diagram, natively using the ExpressRoute gateway. Well, using a preview feature in Azure Virtual WAN called routing intent, we can force branch-to-branch traffic via a firewall inside of a vWAN hub, which we call a secured virtual hub. So we could take traffic in from one ExpressRoute circuit, pass it via the Azure firewall, and deliver it back to a different ExpressRoute circuit, which is exactly the use case we want to achieve here. So if the customer is already using Virtual WAN and they're happy with Azure Firewall as the inspection point in the VNet or in the Virtual WAN hub, this will be a great solution. So as I say, it's a preview service today. I'll provide the link to the preview documentation. No global reach is required, as you can see on this slide. If the customer is not already using virtual WAN, perhaps they're using a customer managed VNet hub, then you could either migrate that entire hub to virtual WAN, or you could build this topology on the screen as a separate hub used purely for the purpose of this transit routing to Skytap. My colleague Daniel Mauser has written an excellent article which digs a bit deeper into this. The link is here. I'll include it in the comments. Workaround number 3 is similar to what we just shown, but this time we are using Azure Route Server and not virtual WAN. Azure Route Server is a product that you can deploy inside of a regular hub virtual network, and it's a way in which you can talk BGP to the Azure Fabric and effectively operates like a route reflector. So as Daniel explains in his article, we can use this behavior combined with some UDR logic and some summary routes to attract traffic from red to purple and force it to go via an existing NVA that lives inside of the hub VNet, as long as that NVA has got support for eBGP multi-hop. So this is a great option because not only is Azure Route Server generally available, you can also deploy this solution with network virtual appliances from other vendors. It hasn't got to be an Azure firewall. And Daniel's guide walks you through the technical complexity here. And it's fair to say there is some technical complexity to instantiate and maintain. And this sort of approach with Azure Route Server would also work, for example, if the customer had an existing IPsec tunnel from on-prem into Azure, so a VPN, whether it be over the public internet or over ExpressRoute. You could use Azure Route Server to bridge the world of VPN on the right, for example, with the world of ExpressRoute on the left to Skytap. So ExpressRoute to VPN connectivity, we call that branch to branch in Azure Route Server, and that's a toggle switch. But this is one of the options, as the diagram shows, to facilitate Skytap to on-prem via an NVA to get that filtering that you may desire, and it doesn't have that reliance on global reach. And then category 4, I won't dwell on this too much. This is an older design which is kind of an amalgamation of workarounds 2 and 3, and this is used historically in some of the AVS designs, which is another Azure dedicated workload like Skytap. And effectively what we're doing here is we're using a chaining of VNets to effectively sort of transpose the world of ExpressRoute into an NVA, which then communicates over a tunneling protocol like VXLAN to another either VNet with Azure Route Server or a virtual WAN hub to then transit that traffic back to on-prem. So you can sort of view these boxes as like cloud transceivers, taking ExpressRoute on one side, push out something different on another side. And it's beyond the scope of this video, but please check out the link here written by the Azure Cat team, which has got some patterns in if you would like to explore that. Okay, I'm going to touch briefly on what the networking looks like inside of the Skytap platform itself. I will say I'm not the authoritative source for this. Definitely go and speak to Skytap, look at their documentation. I'll share some of my learnings in this area and touch on this at a very low resolution view, which you'll have to go into in more detail with the customer. A bit of a busy diagram, so let's explain it from the top down. We've got the customer network at the top. We've got a regular ExpressRoute peering exchange here with these green circuits in it. These are the green circuits that the customer already has, they already use to get to Azure. We already talked about we use GlobalReach, and we connect that GlobalReach circuit into Skytap. And that happens inside of those dedicated edge routers inside of Skytap. So everything so far we've talked about, You know that that Skytap circuit connects back to their customers' Azure virtual networks. And we've already talked about how this gray dotted line here, this is the customer's existing Azure subscription. So all of this logic around circuits and global reach, they manage that inside of their subscription. So let's step down a layer now. So inside of Skytap, the Skytap infrastructure inside of the Azure region, which Skytap manage, there's a series of virtual routers and gateways which are sliced up to isolated customer environments. And you can think about this layer as it bridges the gap between the workloads at the bottom, so the workloads running on either Power Platform or x86 on Skytap, to the world of ExpressRoute. And in this diagram here, I've got a green circuit connecting to on-premises and the customer's Azure VNets, but I've also got a blue circuit, which I'm using for sort of front-end LPAR replication inside of the customer address space, and that's what we talked about a couple of slides back. And then, kind of similar to VLANs on premises, we can start to slice up these networks and attach them to different NICs on different VMs on the platform. So for example, we've got a VM here, or a series of VMs that's got connectivity out to the internet on the red line, it's got connectivity to the replication network on the blue line, and it's got connectivity on the green line to on-premises and the customer network. And this will all have separate IP addressing packaged inside of there and configured by perhaps the customer or by you as the partner configuring this Skytap environment. Depending on your requirements for throughput, then definitely go to the next level of detail with Skytap, understand the throughput constraints here, understand how to best segment your networks. If you're using virtual appliances in Skytap, then they will live on the x86 environment here, so understand how things like default routes work. The takeaway here is this environment here is a Skytap specific environment, Skytap specific virtualization. So some of the things like UDRs and routing and limits, they're separate to regular Azure networking limits. One of the things that we discovered at the start when we talked to the customer was how are they exposing their current VNets to the internet? And then we talked about how should we map that to Skytap. So in terms of how you can get from Skytap out to the internet, there's a few different options. The first one would be you could leverage the green line here. So you could go from a VM on Skytap, could be a Power VM, could be an x86 VM, and traffic can be steered down to ExpressRoute and into the customer's virtual network. Maybe they've got a firewall, could be an Azure firewall, could be a virtual appliance, which is routing that traffic, filtering it, inspecting it, logging it, doing IPS IDS before it then goes out to the internet. So that's one path that you could implement. Another path would be what we would call forced tunneling. So on Azure, forced tunneling is this idea that all traffic to the internet leaves Azure, goes back down the customer's ExpressRoute circuit to their on-premises data center, and then out of their physical DMZ on-premises. You could deploy the same pattern with Skytap. You could steer this traffic out to Skytap via ExpressRoute back to on-prem. Of course, there's going to be latency considerations here, throughput considerations here. And the third pattern is to be aware that Skytap do offer a local internet breakout service. So they can effectively pipe in a customer specific internet route. For example, the red lines here could be internet facing NICs, and they can be stitched through to a Skytap managed internet breakout, which again has got certain throughput limits associated with it. I think the last time we discussed this with Skytap, the throughput limit was in the region of 700 megabits per second. But again, if that's of interest to you, if that meets the customer requirements, that is certainly a pattern that's available. So in summary, our learnings from talking to customers about Skytap and networking is it's really important to talk up front about how they do networking today, try and align the Skytap design with some of the work they've already done rather than going over old ground again. lead with ExpressRoute GlobalReach and ExpressRoute for connectivity back to on-premises. That's going to be the path of least resistance. It's a well-known pattern with the least amount of throughput constraints. Make sure we're thinking about global routing scenarios if you're deploying Skytap in multiple regions. And then finally, definitely refer to the Skytap documentation where required. And if you need to go to that next level of detail with the customer's network teams, engage Microsoft, talk to the network specialist team, talk to Skytap, and we'll find the right people to lean in with the customer and make sure that the design meets their requirements and ultimately is a success for the migration. Thanks for your time.